Hello. Oh, there we go. Hello, one, two, three. Let's see. Why is there no audio? Hello, one, two, three. Ah, see. Perfect. Why is there no audio? Here's audio. Ah, see. Here's audio. Yes. So how can we? Ooh, the AI is driving me nuts.
Data, and the data becomes this incredible barrier to entry, this incredible asset.
The one thing that's important here is that once one robot learns how to do a task, every robot in the fleet knows it. And humans don't operate like this.
Yeah. When do we start seeing robots building robots?
We will put robots on our Baku lines this year. Listen, this is like going to be the largest economy in the world. It's going to be a super impactful business. It'll lead to like ubiquitous goods and services for anybody in the age of abundance. And it's going to be a super fun business too. It's like going to build a sci-fi future we all want. What you're seeing is every major group in the world will get in this space. You have to. You have like no choice.
When are we going to see the first figure in the customer's home?
My best guess is I think.
Now that's a moonshot, ladies and gentlemen.
Yo, what's up, everybody? We're watching
At Figure headquarters.
Why is that one blurred out?
With our friend Brett Adcock, extraordinary, and
check it out.
check it out. So
Over here.
yeah, Figure 1.
This is the original.
Yeah,
Still somewhat functional.
yeah.
They built it in under a year. Brett actually was screwing these things together himself, and it was all about gathering telemetric data so they could build this.
Here's Figure 2. All the C++. Can you do? Can you live long and prosper?
But
High five. And here we go with Figure 3 is the workhorse right now. We just did a tour. I mean, probably saw 100 of these walking through the hallways, on test stands, cleaning dishes.
Brett was just telling us they added a flexible toe too, so it can go down like this.
Yeah.
And before it had this clunky clunky foot here.
And figure 3 has the palm camera.
Palm cam?
Yeah.
They cut
Oh,
about 30 pounds off the
interesting.
weight and 90% of the manufacturing cost.
Wow, crazy.
Yeah.
Amazing. Yeah, it's
fun.
the perfect height between the two of us. Welcome to Moonshots, everybody. I'm here at Figure headquarters with Brett Adcock and DB2. Brett, it's been about 18 months since we did a podcast on Moonshots together, and I am blown away by how far you've come. I mean, that was when we were like, okay, we have to just go all in on neural nets. The whole stack needs to be neural nets to make this work. And that started like, and that was basically 2 years ago now. And then you guys saw Helix 2 today, which is like basically the best release we've ever had. So we'll run a clip of Helix 2 while we're describing it. Because what we saw was Figure 3 running Helix 2 in full autonomy, going to the dishwasher, picking stuff up, putting it away, not pre-programmed. And I loved the human elements of it, like using it to close something that's put right into the dishwasher.
That's the neural net difference. You get unexpected behavior, both good and bad.
That's funny.
The software company, VTOL company now, this has got to be the first neural net platform.
Yeah, the things that you can do with neural nets now just like completely blow my mind. Versus code, like you could never have done a quarter of the stuff that you saw today with the whole body, with manipulation, with things that there's only so far you can really push like coded heuristics into a humanoid robot. It's just a dead end.
Yeah.
It's just not going to work.
Yeah.
Yeah, it's amazing to me how you accumulate data, and the data becomes this incredible barrier to entry, this incredible asset. If you were writing all this in C code, that C code would be, you'd have millions, hundreds of millions of dollars invested. You would not want to mess it up. With the neural net, you can say, look, hey guys, retrain it from scratch. Right off the run. It's just a completely different approach. And that's why people are way under predicting how important or how quickly this is going to evolve, because it's a completely different paradigm.
Well, we've like lived through it. I mean, like I think maybe a year or two ago, we had like several 100,000 lines of C++ code.
Several 100,000.
Yeah, handwritten code.
Yeah,
and
probably $100 a line to write it.
Yeah, very expensive, very hard to like test and like get out reliably.
Yeah.
And like also hard to like model all the different behaviors that we would need to test and then we removed a majority of all that in the Helix 1, where we still had a lot of like lower body control being run in basically the control stack in C++.
Yeah.
And then today we removed the remaining 109,000 lines of C++. That's all that's full body. And that took from like being able to do like tabletop manipulation, like we saw the Kira coffee, the order logistics, like all that's in the last. We even showed like using project. Body to get out of there and be able to move dynamically through a scene while manipulating and planning is just a whole other we basically spent like a greater part of a year refactoring the Helix architecture to be able to enable this to work. You're talking about now like moving through space like a human, having like control of the full body, like
eye, hand, foot, leg coordination. Everything is
sensor data in, cameras, tactile. We have palm cameras. Basically doing inference on board the robot, fully embedded, and then be able to output torques into the motors and do that, a few hundred hertz, in terms of like, that planning and control, and do that reliably on very difficult tasks. Like these are bimanual tasks where it's grabbing and holding things, planning, moving the body, getting things out of the way, making like errors and replanning and fixing this, all done with the neural net now end to end over like a pretty long, like for us, it's like, it's kind of like room scale autonomy. So we can like now like finish the whole room, which is important. And next we're going to graduate to like basically the full house.
That's one of the things really obvious when you're walking around looking at what everybody's doing and working on. You visualize a robot company having lots of people working on microcode or actuators or batteries or whatever, but there's just a huge number of people out there at workstations. They must be working on the neural nets because, it's just got to be such a dominant part of what makes the thing actually look and feel human. And, the motions are so smooth and everybody, when they think about the history of robotics, they kind of chart these line charts, but it's not like that. It's a disruptive change from dropping that last 100,000, 105,000 lines of C code to moving to an all self-organizing neural approach. Completely different future.
It does, like we make these like technology like progress steps, and I think it's been very apparent here. Like every year to year, the whole business looks completely different. In large part of trying to get the hard hands, like all of this stuff in a good spot, and then be able to basically have like more range of motion and speed and torques like a human, and then be able to get like we're all in on neural nets, so it's basically like what is the right data set for that for and post training. Do we have the right training cluster? Do we have the right models? And then deploying those really well on the same humanoid hardware. That's like a full loop. Like we've actually designed Figure 3 to run. Like, if you say like, what is the guiding principle of Figure 3 more than anything else? It was just designing for Helix. How do we design this to run like Helix on? It's almost like how do we give Helix a body?
So counterintuitive.
Everything, just the
so build
head.
Around the neural net.
We built we're like looked at the neural net and we said, how do we like fit like this into a humanoid robot, and what are the best sensors? How should it run? What does the operating system look like? Middleware, firmware, embedded software, like all of it is encapsulated in this like view that we need to go all in on neural nets and do human-like work.
About to release the 2026 version of my Humanoids Metatrend Report. It's a deep dive looking at 100 different robots in development right now, a deep dive into 10 of them, including Figure, 150 pages. You can check it out at Substack for my paid subscribers. Anyway, super pumped. This is a field that's moving at hyper-exponential speeds. So in the beginning, you had partnered actually with OpenAI on software, and you made a departure from OpenAI. And I mean, I guess
Isn't quite accurate, but like
okay, well you can
I mean, like, I think I met Sam and OpenAI team. They were just really interested in getting into robotics, and it was like in their early master plan is to get into like basically shipping home robots, and they really wanted to kind of like basically work on a very intimate like relationship. They ended up co-leading our Series B along with Microsoft, and we started working on basically like a collaboration agreement to help like work on next generation models for humanoids. And we were like super like big then, and we still are on like how do we like language condition the whole stack? How do we use like an LLM in like a lot of ways is just like this like world model. Like, it really understands like in the weights like basically like what things are, what it should do, has a lot of like good semantic understanding. We're trying to how do we tap that for the humanoid? How do we learn from this at scale in some of those representations? And it just like the partnership just didn't work. Like our team just ran circles around them. For basically a better part of a year, and it just came to a point where like it just made sense to just, which we were just doing all the work ourselves internally. We had a whole team here, a lot from like some of the best like labs in the world, and we were putting out like work after work. The Keurig coffee stuff was done by us. All this stuff was done internally. And at some point, it just didn't make sense to train other folks on how we basically build AI models internally for embedded systems like a humanoid.
Did it turn out that LLM matters at all in physical? Like you could start with an open source LLM and tune
it like a VLA, like a vision language action model?
Yeah, you basically like I think the LLM is definitely a certain piece of this. Like we basically want to like take it like the semantic grounding in like a VLM.
Yeah, like the common sense. You know,
yeah, like how do we like understand from this? So you know, which we have in Helix today, super critical. But like getting to a point where we can understand physics in the robot and have it like really be able to plan and reason at fast dynamic speeds was something that nobody in the world's ever really done before.
Right.
And I think that's the work that we I think have been excelling at and really love. It's just like how do we get it to like understand physics?
I think most of our audience probably knows this, but just to rewind the tape, the LLMs, GPT-2, GPT-3, built entirely on text data, scraped right off the internet.
Yeah.
And then they supplemented that with a ton of other data, also in text form. And that creates this machine that has tremendous amounts of common sense. And if you ask it, hey, do you know how to play soccer? It says, yeah, of course I do. But then you try and install it in an actual physical moving machine and has no idea what it's actually doing.
Yeah, I mean, like we seem to like touch everything in the world.
Yeah.
And we have this like really high dimensional robot that has like 40 plus degrees of freedom. So like and so like on the surface area, just the math around this is like the dimensionality space is really high. So you have like 40 motors. They all can spin 360 degrees.
Yeah. So
the amount of states the robot can be in like positions is like 360 to the power of 40. So there's more states of the humanoid than atoms in a universe.
That's a lot.
So
So you're not going to simulate those one by one.
Yeah, exactly. So like,
That's funny.
Then I need to like understand these fine contact dynamics of like.
That's
I need to
interesting.
grab this water bottle. Like, where do I position my elbow, pelvis, like torso, head, like fingertips? How do I plan to grab this? Is and then how do I put pressures on there? And how do I understand those representations really well?
Wow.
From observations now into actions that I'm doing at test time.
I never thought
this is
building robots would be that complex.
Yeah. No one knows this is a water bottle. They probably knows like I need to grab it from the side, and then but like all this like all this implied physics that we need to do here. Just we have to go train models to go do that.
It's actually kind of
It's
weird.
insane.
It knows how to do it too. The LLMs feel like they can do things, intuitively, and then they completely fail.
I mean, you can. We've done this. I've done this. You can zero shot the LLMs inside a robot. We do it. We still do it.
Oh, really?
Even actively. They just can't do anything.
Just for fun, just to watch them fall.
Yeah, I'm like, I'm kind of interested. Like, part of what I've been doing is like, can we just like, the other day I was like, can I zero shot? Like, I'm working on this new AI lab that I founded recently called Hark. And we have this new AI model here that is just like, it's just completely
Wait, you founded a new AI lab? Well, rewind the tape here. What?
Yeah, I started a new AI lab.
I sent you this. Did you? I did. I sent. Yeah.
Yeah,
I'll send it to you again.
Working on, and we have like some new AI models, and we actually put one of them into the figure robot like this month. And I was like, okay, let's just zero shot. Let's give the LLM, let's give the model. This is like a multimodal model. Let's give this access to just like basic commands, like basic like X, Y, like basically, can we give it like acceleration and X, Y coordinates for navigation? Like basically a joystick. Can we give it a digital joystick?
Yeah.
And I asked it to like find the exit sign and just like go to that and get out of the building. And it just and unfortunately it was going in the right direction and ran into like a clear glass wall.
Kids do that too.
Yeah, exactly. So
Who walks into a clear glass wall?
It just doesn't work. Like you're missing so much like world understanding of like what's really happening. How do we move?
We see what you're saying.
Thinking, like, it's pretty simple to.
So LLMs can't drive robots. That's a very interesting perspective.
Humanoids are moving.
Right?
The pelvis and head and torso and hands and arms, like when you're reaching out to grab something over a table, your pelvis is moving backwards. Like it's very very difficult to command like very high
robotic physiology.
Yeah.
Out of China, some of the government employees said we've got a robot bubble. They have 100. I don't know if you saw that article that came out. We have 150 plus robot companies in China, and I mean, there's a lot going on there.
Yeah.
In the U.S., I would say maybe there's 10 serious players. I mean, 2 or 3 who are extremely serious, including Figure. there's a lot of potential humanoid robot companies. I was just at CES and saw, it was a humanoid robot explosion.
Yeah.
And then as many or more hand companies, which is interesting.
Yeah.
So I go back to sort of the early 1900s.
Hand companies. That's an interesting concept. Been robots.
And like 200 or 300 tire companies, and then this massive consolidation occurs, and GM and Chrysler and Ford sort of buy and consolidate. What do you think is going to happen with all the robot companies today?
I think it happens in every industry like this, especially in deep tech. These will all consolidate down to a few groups globally.
Do you have a guess? Is it a triopoly? If that's the right description. Is it, more than 10, less than 10?
It always seems
far less than 10.
Far less than 10.
Yeah.
Globally.
It always seems in the U.S. anyway to settle down to 2, 3, or 4, but the borders are not obvious. Like with cars, car, right? And actually, you had cars and trucks, and those were kind of separate for a while.
Well, you also have different designs. Like I want the plush interior.
Right.
I want the Sportster. I mean, and that I wonder, is it going to be, are robots going to be differentiated by their vertical application, their personality?
Exactly. There's so much more variety possible in robotics.
Yeah, I think everybody's just like taking for granted how difficult this is.
Yeah.
Like this is like, you have to go out and build like basically like pretty novel, very, very difficult hardware.
Yeah.
It needs to be relatively cheap. Then you got to figure out how to make neural nets work on it. And then you got to make neural nets work on it at scale. And then you got to manufacture at scale. And then you got to get these products out reliably that all work every day without any human intervention.
Yeah.
And, I think we talked a lot about this, like how we're doing like K-cup coffee work. Like I haven't seen any single humanoid in the world do that, or able to do that today globally. And that's been 2 years.
Yeah.
I mean, by the way, a lot of the video we see is actually teleoperations. I wonder if people realize that. A lot of the robot companies are teleoperated versus fully autonomous. What we saw just walking around here was a 4-minute long, fully autonomous operation on Helix 2, right?
I've never, I've built a lot of businesses in my day. I've never seen so many companies with a human in the back commanding the robot and putting out updates in my life. I've just never seen it. When I first started figuring stuff was coming out, but now it's like every week is somebody just teleoperating a robot and putting out a video, and it's just, it'd be the equivalent of like I have a self-driving car company and there's a guy in Tennessee driving it, and we're like marketing it as like there's no humans in it, it's self-driving. We're putting out teasers. We're in a lot of cases now those companies selling the service. Like, so I think like if you want to do this right, you got to believe in neural nets all the way down the stack. You got to basically build for general purposeness.
So the parameters that it's going to define the successful top 2, 3, 4. The neural nets, manufacturing.
Okay, I would say what's impressive today is not manufacturing. You could probably solve, we're pushing on manufacturing hard, but you can probably solve general robotics with 100 robots. What's impressive is like a full end-to-end robot that is generalizing to an unseen place. Like you can drop it into an Airbnb and be able to do long horizon work with neural nets. I mean, any long horizon work in unseen places.
What do you define as long horizon? Hours, days?
I would like to see days of work. Yeah. Fully autonomous days of work, and at the very least. And we're like so far from that. You have like robots out there doing like karate, jumping, which is like these are like pre-programmed open loop behaviors. They're not impressive. We do that. We've done that stuff here. Like you know what I mean? We've done like the open loop behaviors. It's just there's just like any college kid in the dorm room can do this with a robot. And so I think like that plus teleoperation is not impressive. You could build a shitty hardware and still teleoperate it and put out videos. That is not hard.
Yeah.
What's hard is to do full end-to-end neural network in unseen places or generalized to this. And then if you can solve that, then the next step is like, how do you get that out at scale? But we are still in the like, who can solve general robotics phase of the humanoid phase. And it's just not impressive if I can build 100,000 robots right now that like need teleoperation or can just only do open loop replay. Like it's just not cool. Like if we like, Brett, your only job is to build 100,000 robots right now. Yeah. We have the capital to do it and we can do it. But like what we really want to solve is like, I can give you 10 robots and they can go into unseen places and do real useful work. Like that's what's going to differentiate.
So iterate that until it's right and then mass produce.
You basically want to be bringing up mass production in parallel. because like building like high rate manufacturing for humanoids is going to be super hard, and you're going to like have to go through like a lot of iterative design process. So that's what we're doing now. We're bringing up higher volume manufacturing as we're like learning how to build true general purposeness. But my view is like, if you think about these level bosses that happen that will hurt, like that you need to graduate to. You need to graduate to doing like, first very short periods of like neural network, which we haven't seen a lot of in the world today. I don't think there's anything over a minute long in the world that's doing neural nets continuously today in humanoids.
That's amazing.
Everything's cut, all the films are cut or teleoperated. It's pretty crazy. So
I'm really glad you're telling us that.
Yeah, no, I mean, like that's
So,
you watch any video clips, you want to see it uncut, you want to see it done with neural nets, like not teleoperated, like, and then you want to see stuff we showed you here in person today that are running for hours and hours, and just like we run these robots with neural nets.
The Kung Fu videos, whether they're teleoperated or fully autonomous, are actually fascinating and scary when you see them.
But the technology around there is not great. I mean, you're basically putting somebody in a mocap suit.
Yeah.
You're having some guy like do karate chops or walking around.
Right.
And then you're running that open loop. You're running that blind. You're just hitting a replay button.
Right.
And you can do that with a very simple like RL neural net. Like you can basically do deep mimic on this. Yeah. And it's super simple. Yeah. Like there's like open source code for this. You can do with like basically one GPU on your desktop, and you can do with any robot. Yeah. And every robot has a very tiny amount of computer. These are single million parameter models. They're very small. You don't need a lot of memory, and they're very simple to execute. Yeah. What you really want is good closed loop of control, where it's reasoning like at over like kind of like 200 hertz or 200 times a second.
Sure. And
it's dynamically responding to the scene.
Yeah. And
that is literally 100,000 times harder than doing open loop replay.
I wonder what the human sort of cycle time is. How many hertz?
Oh god, much lower than that.
Yeah,
I would imagine.
One thing we've seen about a robot is we can like balance on one leg like better than a human.
Yeah,
we just have like much better, like faster like dynamics.
Can we talk about the speed of development here? So 2025. I'm just trying to imagine, and you put out this beautiful, post every week on X about the progress in the robotics field and what's going on here at Figure. And it's just constantly, locomotion was a big step forward, excuse the pun, for Figure, just seeing it walk and then run very naturally. What else was significant in 2025 for you?
I mean, we launched Helix in 2025, about this time last year, about a year in now. I think that was like highly significant. Like we basically figured out how to run like basically like longer, like over long periods of time, neural networks on a robot. How do we get the data for it? How do we train models? How do we deploy to test time? Mm-hmm. How do we get to like you watch like package logistics? I think you guys saw it running. Yeah, it was like running awesome. It's been running for days now. Yep. And it's just like it's a neural net all the way down the stack. It's learning how to grab packages, kind of like individualize them, find the barcode, position it down. It'll even pat the package down so the barcode reader below can see it and scan it. And it's doing that at very high, it's doing that at high accuracy, and it's doing that at high speed. So
high speed though, that's the part that it's visually
it's like crazy.
Because a lot of what you see in robotics,
it's as fast as a human would do.
We like our last, we see air now. Like the last one we did we had one air over 67 hours, just continuous.
Over 67 hours.
Over multiple robots.
This thing is
crazy.
Yeah, it's doing an operation every second or two. So 67 consecutive hours of that is a lot.
So if you had to guess at...
So I would say Helix is a big one, and then Figure 3. So Figure 3 is like a huge step change for us in hardware.
If I could, what do you see then going in 2026 here? We got the next 11 and a half months. Yeah. What are you excited about?
We will build our entire roadmap around Helix 2 now. We will basically, now Helix 2 can go from doing the logistics use case, stationary, to walking and moving, and basically do long horizon full body control. So that means and then we basically have now integrated all the sensors, tactile, camera, palm into the stack, and then we're seeing improvements overall in the policy layer. So we're getting better and faster about basically taking data and basically running it on board the robot now.
So I wanted to ask you what defines Helix 2? Because you're probably incrementally improving the neural net every day.
Yeah.
So what is the...
We had a couple big steps. One is we basically have integrated, a fully learned, what we call System 0, which is our controller, into the robot. So the robot has a full body reinforcement learned controller in it.
Okay. So
basically now we have literally no code written on that robot. So it can basically move the whole body itself using a full basically learned controller inside of Helix. We call it S0.
Has anyone else ever done that before? That's got to be.
There are reinforcement learned controllers out there. Like a lot of the karate stuff you see and things like that are that, but nobody's really integrated that in the whole body for learned manipulation and perception. And nobody's showed that actually working with moving around and doing things that we showed today.
Yeah.
I actually don't even know if anybody showed it stationary standing and doing learned policies. Actually, probably not in the world. So like getting it integrated into a stack now that we actually use going forward. I think one of the things we learned at, like, we were in BMW last year, and we were there for we did 6 months, like redeployed like our Figure 2 robots every single day.
Yeah.
The biggest thing we learned there is like the stack we had, I think about 80% of the things we got right and 20% of the things we got wrong. Meaning, like, the things that we got wrong on, we didn't want to scale. It was working. The robot ran every single work day, and it worked. But then we learned, like, okay, I don't want to ship 100,000 robots in this like architecture stack. It's just like too hard to scale.
Yep.
It'd be like too brute force.
Yep.
And so we basically worked on for almost a year now on, like, okay, what is the idea architecture where we can go out and accumulate large sets of pre-training data, put it in the robot, and it can just like do this work, and we emerge generalization from this. And that's what you're seeing today.
So Helix 1 had the C code in it still. So what defines Helix 2 is
Helix 1 had a lower body controller that was still written in C++, and everything else, full upper body, was full neural nets.
Okay.
And so we basically completed now the full body.
Okay.
And then in doing so, we also did some work on our system 1 level, where we integrated all the sensor modalities now from the hands and the rest of the robot into the stack. So, like, for example, we now have tactile sensors on every fingertip that we're using on Figure 3, as well as palm cameras to understand how we're sometimes occluded, and sometimes we want to better understand how we're grasping items. So we put a bunch of stuff about we're picking pills and stuff out of pill cartridges that you like literally are occluded from the hand. Your hand's like literally in front of the head camera, but we still really want to understand where we're going. Yeah. So I think so now with Helix 2, we basically have a full stack end-to-end with neural nets, and we feel we feel confident in scaling the pre-training data set into Helix 2. I'll even go as far as, like, we've designed Helix 2 for the pre-training data set. And then we designed the robot for Helix 2. So we've designed everything around data. Yeah. And how do we get data at scale? If you're in the neural net game, it's like a data play. Right. It's like how like high quality and diverse.
So it's experience. It's just gathered experience in the field in all kinds of circumstances.
Like, where can we
weird
find?
In that, I know everybody knows this already, but it's accumulating and it never goes away. It's incredible,
unique data
progress. Well, yeah, you teach somebody how to scuba dive or how to play piano, and they have that knowledge. They live, then they die. Then you have to teach somebody else. This is completely accumulating.
Hey, Bliss. Here's the thing. Max just said, he just said,
once one robot learns,
no one ever forgets his name because he's very aware of that. Oh, now he wants to come join us. That's funny. So I'm gonna leave that message, and he's gonna be so confused.
I watch kids learn how to do stuff, and they just don't listen.
Vulcans do.
I wish we did. So 2026 predictions. What's your boldest predictions for Figure? What is your goals for this year? What do you imagine?
Yeah, I mean, we're spinning up BACU like production enormously right now for Figure 3.
So you said something like a robot every 30 minutes, you expect?
We're trying to get there in the near term right now.
Amazing.
Which you guys saw, we walked through BACU today. What did you guys think of BACU?
Yeah, it's a lot of humans.
I wish everyone could see it. I guess it's all secret. You can't camera through there.
We haven't. There's a lot of IP there because, like, you see exposed boards and actuators and stuff.
People with
it's cool, right?
If we get some permissive video, maybe we can mix it in here. But so whenever there's a lot of humans, when do we start seeing robots building robots?
We will put robots on our BACU lines this year.
Okay.
And then phasing humans out of there will be a combination of getting more robots there and doing more high volume like automation over in BACU.
Okay, so that's the first 2026 objective.
We want to scale up robots in BACU for sure. The second thing is we want to scale out robots in the industrial commercial workforce.
Yep.
So we have like multiple clients now we've signed. They are like buying or leasing robots from us, and we are going to get those out at scale in 2026. We know exactly where we're going geography wise, what use cases are going to be, deployment schedules. We want those to be Figure 3s, so we've just retired end of last year Figure 2s, and now we're basically building the arsenal of Figure 3s out. Once we're scaling up manufacturing to get them out to the world and run every day. We like the commercial workforce because it really helps harden our ability to run robots every day. Like, what we're here to do is we're here to build robots and run them in the world, and they run 24/7.
Your ideal customer is who? I know a lot of people would love.
We have, to be frank, so much demand for customers. We've talked to 50, 100 customers or so in the last 6 to 12 months. We really want to be kind of all in with a smaller group of customers and really spend time with them, integrate well into their facilities, and do well. We're still at this we're still early, right? We don't have like thousands of robots right at these places. We want to as fast as we possibly can, but like once we get to certain, like, I mean, we could probably ship like, I think we could ship an enormous amount of robots into the current customer base we have now. Like, so we see like, you know, we're kind of good now for the next like 2 or 3 years in terms of like, we have so much demand. Like they're kind of waiting for us to like ship at scale.
Leasing versus sale? Is it,
yeah, we have like,
work as a service?
We have like a, you know, we really like the leasing model. Yeah. Humans are leased. Yeah. So, you know,
thought of it that way.
Yeah.
At least they used to be bought way back.
At least these days.
Yeah, you lease humans. So we lease humanoids today. You know, we won't be we're not opposed. I think what really matters is trying to figure out how to find the right distribution to get robots out of scale. Yeah. Like it'll really help us get really good at what we do. Like it's one thing to like show a demo or whatever else, but like, you know, when we had robots at, you know, in a commercial customer last year at BMW, like it was just, it taught us a ton about like running it every day, fleet operations, safety, like repair and maintenance. Like there's a lot of other things that need to come through on the ecosystem that we need to get right. So I say second thing is like
AdCom is
and then,
a true G. I'm just saying this for the record. And the volume has to be very low because I don't want to hit any like copyright issues on YouTube. But
like basically almost like, you know, like almost perfect memory, what's really happening or what's going on in your life, that can maybe talk to you, almost be your companion. I mean, and then go off and do things that you would like you an everyday human would want to do. And I would expect them to get up to speed on those tasks at or faster than human can.
Is there 2 different models then driving it? The VLM model for the body and the physics and the embodiment versus an LLM for conversation and memory?
We believe this all comes down to like one model at the end of the day. That is one omni model that is trained early in pre-training that helps fuse all this together. But yeah, you could think of it like we need to have speech. We need to have like language condition policies. We need to understand physics really well. We need to remember things and be able to recall that easily. We need to have some sort of personality on the robot. I think one thing that you're going to see more and more is we really want to make this robot something you can spend time with. Yeah. And we've been really focused on getting the core building blocks built. But like over the next year or 2, I think you'll see us. I think I just want a robot in my home I can talk to. Sure. I can remember things. Talk to my kids. My kids come home like sad from school or something. I want the robot to understand that. Have the EQ, like self-awareness to see that, talk to them. Like I think all of this is like something
emotional quotient.
Spending more time on now internally.
That's right. Imagine that, going home and your robot understands you're sad. It comes and starts talking to you. Boom.
We have like one neural net now that's basically there's no like libraries of neural net that we pull down. So there's no like dishes neural net or like or like logistics neural net that you saw here.
Yeah, because you know at scale, like if you teach the thing every physical motion, has massive number of combinations. The storage is actually dirt cheap, but the processing is very expensive.
Yeah, even better. We've basically seen positive transfer now with all this data. Yeah, like coming in, the robot can journalize better with more information. Even if
it's weird. Like more knowledge is better. Yeah. It does cross. Like playing piano makes you a slightly better soccer player. Yeah. But also, you don't want to run the whole parameter set for piano playing when you're playing soccer. It's an interesting little hybrid problem there.
Yeah, you don't want to nuke it. Yeah, for sure. Yeah, I mean that's where we try to build best in the world models here, and build a great team that can ultimately deploy robots that are useful. I think showing, like like this type of usefulness, like either it's like a lot of stuff you saw today, and a diversity that is super important for a humanoid robot. It needs to be able to do everything a human can, which is like, and the distribution curve, it's like, we probably do like billions or trillions of very unique things in the world.
Yeah, one of the things you said on our tour that totally tells me you're on the right track is that you're using normal GPUs for the training, like everybody, but the inference time compute is on super, super fast, dedicated non-H100, GB300 hardware, which has got to be, at least a factor of 10 or 100 cheaper and faster.
Yeah, it's also running fully on board.
And it's running fully on board.
So we can basically do very fast inference and policy deployment. Yeah.
And it's also not sucking down the entire power of the robot.
Yeah. Yeah, I mean, you also have an issue where we've also run models off board the robot, but if we lose communications or have some...
So I wanted to go there.
You know what I mean? Like if you lose internet, it's hard to do work, and it's like most humans...
We hit on supply chain, batteries, and comms. So on the comms side...
How are you doing? I hope everything is amazing and you're doing wonderful. So, Jim, this is that you're asking about. I have some sort of news. Things are just really, really moving fast. We just have a huge, massive leap. It's some news was released. Just gonna speak to my team about this. So I'm waiting on this. Well, it was released about 2 days ago. I believe with this, we could have like an extra 20% cost reduction. So before I'm sending anything your way, I just wanted to speak with the team to make sure that I am correct on this and that I'm not hallucinating. But yeah, more likely than most likely, uh, more likely than not, that's going to be the case. So I'll send you some stuff while I got it going. Once I get it going, I'm sure that you weren't in a hurry for this. Yeah, that's great news.
Do you imagine you're going to be running like a 6G network on there besides Wi-Fi? What's going on in batteries these days?
Yeah.
Yeah.
We have from a network perspective, or communication back to the robot. We have Wi-Fi on board. We have a 5G and SIM card, eSIM on board. So you can text the robot. You can have
James.
Yeah,
Yes.
you can have a network outside of like a Wi-Fi condition, and then we also have Bluetooth on board. So almost like a walking phone or something like that you would think of.
Yeah.
So we want you really want like connection at all times, but you also want, ideally you want a connection all the time, but you also want the robot to be able to perform work without a connection.
Yeah.
So you really want like a lot of onboard intelligence, that we basically, in case you lose internet, the robot's like not bricked. Humans, for the most part, can do work without their cell phone.
Not teenagers.
Yeah, that's going away
Not
fast.
teenagers. Yeah. Okay.
So
Yeah.
batteries. They've been improving. What's the battery life right now? I love the charging mechanism, by the way. For those who don't know, you're charging basically through your feet.
Through your feet.
Yeah, no connector. You just stand.
Yeah, which is
You can just
stand in
stay
place.
there.
Yeah, that's
Inductive
great.
charging.
It's really cool.
What kind of battery life are you getting? What do you expect in 2-3 years to get for battery life? So today it's what?
Yeah, we run basically around like 4 to 5 hours per like full charge on the battery, and if we're starting at full battery life,
Sure.
and then through full depth of discharge, and then we can like charge wirelessly about 2 kilowatts through the feet inductively. So it's and we have about a 2 kilowatt hour battery pack, so it's about an hour or so for a full charge on the robot. So we can do like 4 or 5 hours on, an hour off.
That's great.
And yeah, it's great. I think folks are over-indexing too much on how long the robot can run on a single charge.
Yeah, I don't
think it's
expect.
really,
I don't expect there that many tasks.
Humans take like a few hours in. You're not like, you go take a little break, like do this stuff. So it's like, I think there's
Sure.
ample time to do opportunistic charging. Maybe send another robot in. We also can charge. We basically can put like this little thin mat anywhere in the world. Like it could be like at a conveyor system or wherever else. It could be at home in front of the kitchen. And you can just charge there while doing work, which is really cool.
Yeah.
So you don't have to like have any wires or things like that. You're pulling from the.
Well, I think one of the greatest value adds you're doing right now is people are over-indexing on all kinds of weird things because they're physical beings and they're watching the robot do physical things and they're saying, "Oh my God, can you believe it can sprint now? Oh my God, it can do a backflip now. Oh my God, it can do." And you're like, well, it depends whether you programmed that in C, or you teller operated it, or did it actually learn this?
Yeah, I think most of those are open loop. They're just like replay buttons.
Yeah, exactly, and it's just so hard.
Captain Block, how are you doing? I hope everything is amazing. I just wanted to follow up with you because we too many conversations officially on sidelines, lineable everywhere. So just want to confirm, do like in terms of the landing page, where did we get to? What was the last conversation? I know that we went through. So call to actions, the main, excuse me, the lead magnets. What is the big offering to push on this landing page to get people to sign up for? As the top of the funnel of your country. Because I know this keeps on dealing with. So make sure we get this correct. So to let you know, with your email, you're going to be paying some like $6. Skip sponsorship offer that you have worked you on, and how to make a decision. So, actually, it's because you have one.
So when people say, well, how long does it run with one charge on a battery? You're kind of relating it to your cell phone.
Yeah.
But it's not relevant in the inflection we're going
Yeah,
into.
I think you just gotta, like, the summary here is just like, I need to see like real open, like I see like real closed loop control of a robot moving around, touching and moving things like a human would.
Yeah.
And that's where the hardest problems all sit. And that's where we've seen this huge wave of like humanoid explosion, like you said, out of China and things like this.
Yeah.
But we've seen this like very steep drop off from getting to that point next, which is even like, show me a minute of the robot doing Keurig or something like that, uncut, closed loop.
Yeah, real time.
Yeah, like, and I just like, you just haven't seen that, and I think you will, and I think there's like a lot more levels to go from there, and that took us 2 years to go from like a few minutes of tabletop manipulation with neural nets to a point where we can do like kitchen work, like room scale autonomy, and that was 2 years of working 7 days a week. We're here like a lot of nights getting there, so it just gives you a little sense of like, you're not going to do that in 6 months from there. So I think like that, there's a lot of both hardware, low level like software, firmware, embedded system, sensor, and then like neural net, and then data. All of that came together to build this. Like we couldn't have done this work on. We couldn't do the same work today on a robot that we could go buy today off the shelf.
You vertically integrated. I made the choice to vertically integrate, but supply chain. How much supply chain ties back to China?
I think in like the next, like, I think by summer we'll have almost none of our supply chain in China anymore.
And
that's amazing.
U.S. versus China, sort of AI and robot competition.
Fully sustainable within USA.
No,
That's
like
amazing.
I spend a decent amount of time in China. I love it. China is great. Like I go there and it's you're watching TV here in the US and it's just like this massive conflict and battle and everything, and then you go to China and everybody's just like trying to help and win and trying to work and collaborate, and it feels like a startup incubator. And it's just
like a one-way competition.
It just feels like everybody's in team human, team humanity to go win. And it's so great. Then you come back here, you're like poisoned with all this like stuff online and like articles and television.
It's
and
interesting
like,
perspective.
It's not like that when you're like on boots on the ground and going to do this. It's like, let's go as one and go win. And I just like love that spirit.
Well, China tries to go as one and win, and then take your IP and just duplicate it on their own.
To bring abundance.
That's what China will do.
And just make it like a sci-fi future.
Sell your robots on AliExpress in 2 years, bro.
Run Star Trek is what we talk about. It's like, I see figure on the moon, figure in orbit, figure on the ocean floor.
100%.
So the equivalent, like you guys make your own actuators, motors here, and part of that is because you want the exponential growth effect. But part of that also is the supply chain just doesn't exist to give you the parts here.
Well,
Yeah.
the
In China,
improvements. I mean, you're talking about you were just and I were talking about this. The improvements made between Figure 2 and Figure 3,
yeah,
because you have all of the ability to iterate in terms of speed and cost. I mean, the numbers that you shared on cost, I was like 90% reduction.
Yeah, we
Is that
reduced
correct?
costs like crazy on Figure 3.
It's crazy.
I think we vertically integrated because we had to. It would be great if we can go off and buy like motors and we can plop them in the robot. It doesn't work like that. It'd be great if we can go by hands and just like screw them on to the end. It just literally doesn't work.
yeah.
If you go through the engineering work to basically understand how we do comms and power and sensors and failure cases and thermals and low level firmware and embedded software, like it just like there's like one of the cost, something breaks in or reliability, something breaks in that equation, and you're like left with like hopefully the vendor fixes it or you die. It just doesn't work. None of the stuff like the technology readiness of these things are really low. We would love to have gone out and like bought all this stuff in the early days. We tried and we basically just failed at all of it. So we had like, okay, we need to go design ourselves. And then now we manufacture, like we do all final assembly and everything here.
Yeah.
And we do that, in some cases, because like nobody knows how to do that well. We do that a little bit for IP. Like we really want to control that here and understand like what we have, like people have access to. And then we also want to get good at making a lot of robots. Like what we need to get good at long term is like probably a few things: getting data at scale that can run neural nets, and then like basically doing Helix really well, and then making a lot of robots. And then getting those things out at the world at scale. Like it's a pretty simple equation in the day.
It just feels like the journey of getting Figure up and running must have been so much harder than it would have been in China. But then once you have everything built in-house, all the actuators, training the neural net and everything in-house, then you have a massive advantage versus anything going on in China. Because if you'd been locked into a supply chain, it only has certain models and makes.
It's like even if we used like an existing supply chain for all this stuff, the robot wouldn't be able to do.
Oh, that's a really cool keyboard.
If you go out and buy like a humanoid robot off the shelf today, we can't get it to do this.
Yeah,
we've bought robots off the shelf. We've looked at them. Like you can't get them to do this work. Yeah. They don't have the right sensors. They don't have compute. They don't have thermals. They don't have the right the hardware, the hands, the head, all of these are built around our neural net stack.
Yeah. And that's the new thing too. The neural net is incredibly integrated with this specific hardware.
If you watch folks that are trying to buy these robots off the shelf, like say from China, they'll end up retrofitting them themselves with these giant backpacks. They'll have like power, they'll have compute there, they'll have thermals, they'll have a wire hanging out, they got to hook that into the back. It probably has its own local battery. They'll hook it into the back of the robot. They have to take it and they have to overclock it. And it's just the wrong way of doing this. Yeah. It's like a hard thing. It's like doing rockets and like buying a rocket and here's we're gonna put stage 2 on the side or something like that. It just doesn't really work at scale. It works for in the early days, like hobby grade, like demonstrations and things like this. But if you really want to do robotics at scale, you're going to have to go design it yourself.
Yeah. Looking at the companies coming out of China, Unitree, Engine AI, and so forth, do you have which are the ones that you're most interested in, excited as friendly competition, if you would?
Yeah, I think one thing that's great about China is we're just seeing it's like, as you mentioned earlier, like this explosion of like really great talent and robots coming out the door.
And great entrepreneurial work ethic there, right?
It's awesome. Like it's great. And I think it's just good for humanity and like this needs to happen. I think the thing that we I think we've not seen any like closed loop, like AI, like control from these systems at all.
Yeah.
We've seen a huge lack thereof of that stuff. Unitree's like, here's the robots, we'll sell them. And they're doing a ton of like basically open loop, like local.
Yeah, they're hand controllers.
Yeah, so I think like doing that is it's almost like it's orthogonal work from designing the system the right way for full autonomy. But I think if we had to think about like who Figure really competes with as our main competition, it's certainly China. So like as a whole,
for manufacturing, for human low cost labor.
I think just for humanoids, like we really don't see anybody else besides China as a real competitive threat today.
Fascinating. Do you rumors about Apple getting into the business? They cut down their car project, and the rumors are that they're heading towards humanoids. Have you heard that?
We've heard this. We've had I've been in conversation with every major tech company in the world last 12 months.
And then NVIDIA and Google and even Sam. Everybody's making noises about
Meta, Amazon. Yeah. Listen, this is like going to be the largest economy in the world It's like roughly a little under half a GDP is human labor.
$50 trillion.
Yeah, this is like the next great place to be. And I think it's going to be super impactful business. It'll lead to like ubiquitous goods and services for anybody in the age of abundance. And it's going to be a super fun business too. It's like going to build a sci-fi future we all want.
Yes.
It's going to feel like it's going to feel like 2080 up in here.
Yep.
Wow, it's going to feel like 2080. I like that.
You have to. You have like no choice. You have to have a
major group being Apple, Microsoft, Google.
I think every major player that wants to do this. I think the thing that I think is gonna be hard is like we're doing like rocket type difficulty and design here.
Mm-hmm.
So it's like if Meta is doing like building rockets, you'd be like that'd be crazy.
Yeah.
And I would think maybe the humanoid is probably up there with like rocket design. It's certainly harder from an engineering perspective than when I built Archer. Building like electric aircraft, and that was hard.
Yeah.
That was these were 6,000 pound aircraft. 12 motors, 6 independent battery systems. We built our own control stack and embedded systems. Like, we did all the structural design ourselves, things like this. So I think it's probably up there with like some of the hardest hardware on the planet. And you just have got to be all in.
Well, let me ask you about that because we were talking backstage at Abundance 360 last year, and you had the basic tech stack had 6 layers of competency. You could probably rattle them off the top of your head, actually, but. Yeah,
this is for Archer or Figure?
This is for robotics prior to neural nets, I guess. So it applied to Archer and Figure.
Sure.
But what were they again?
Like Archer was basically like a flying aircraft.
Yeah.
I basically build electric vertical takeoff and landing aircraft.
Right.
That is basically it's like a flying robot is what I meant.
Yeah.
That has, it basically has battery systems on board.
Yep.
Has electric motors.
Yep.
Electric motors just basically a stator rotor gearbox.
Yep.
Pretty simple. We have a little bit more sensors in our actuators than that, but for the most part, and there's those encoders and stuff in there, things like that. Okay. You have basically a control software. Like how do we control this thing and make it move around?
Yep. And
in the case of Archer and Figure, it's very over actuated system. So Archer has 24 degrees of freedom. We have propellers tilting. We have pitch on the blades. We have flaps on both the tail and the wing, tail and the wing. So and then Figure we have over 40 or so on the system.
Yeah.
You have embedded software on board and sensors.
Okay.
So how do you get the compute, sensors, and embedded software all talk to each other?
Yeah.
Then you have structures.
Okay.
So those are kind of the core ingredients of a robot or something physically moving through the world.
Yeah. So then my question is, traditionally the employee base would be experts in 1, 2, 3, 4, 5, and 6.
Yeah.
And they'd be really, really good.
Yeah.
So then you come in and overlay this with Helix, and you've got this massive neural network thing. Is that a 7th competency, or is that something that permeates the other? Or did you take all of your microcontroller experts and start training them on neural networks?
The next thing Archer is how are you going to plan? And you do it through a pilot. We have my aircraft Midnight is a piloted 4-passenger aircraft. So who's doing the planning and basically higher level behaviors in the stack that tell a lower level control and code what to do. And here at Figure, it's been changing over time, but now it's entirely neural nets with Helix 2.
Yeah.
So it's who's gonna? What is the highest level behavior telling the rest of the stack what to go do?
Yeah.
Where's that? It can come from a human. It can come from a joystick. It can come from an open loop behavior, which we see we talked about before, or it can come from a neural net that's doing the planning and reasoning. So the kitchen demonstration you guys saw today and we released, what's telling the robot what to go do next. And what to pull the rack out of the dishes and to go grab the cups and not the coffee cups, but the water cups. That's a neural net making that planning.
Yeah.
In the case of my aircraft at Archer, it's a pilot determining when to take off, when to hover, and when to transition into full.
Hello.
Yeah.
And then how to suddenly descent.
What's a different type of neural net?
It's a human biological neural net. Yeah.
This episode is brought to you by Blitzy, autonomous software development with infinite code context. Blitzy uses thousands of specialized AI agents that think for hours to understand enterprise-scale code bases with millions of lines of code. Engineers start every development sprint with the Blitzy platform, bringing in their development requirements. The Blitzy platform provides a plan, then generates and precompiles code for each task. Blitzy delivers 80% or more of the development work autonomously, while providing a guide for the final 20% of human development work required to complete the sprint. Enterprises are achieving a 5x engineering velocity increase when incorporating Blitzy as their pre-IDE development tool, pairing it with their coding co-pilot of choice to bring an AI-native SDLC into their org. Ready to 5x your engineering velocity? Visit Blitzy.com to schedule a demo and start building with Blitzy today.
Let's talk into application layers. So we're seeing your movement into the home, besides the industrial base and such. And healthcare is going to be a big part of this. Elder care, helping people stay healthy at home. By the way, you just came through Fountain. Through Fountain Life. I did. How was the experience for you?
Thanks for referring me.
Yeah.
It was great. I went down to a clinic a couple weeks ago.
Which one, in Orlando?
Orlando.
Yeah. Headquarters. Yeah.
I didn't know what to expect. I've done like full body MRIs and the CT scans and blood work before, but like got there, it was basically a full stack. I mean, you know this, but like it's a full stack.
Everything measurable about you.
Yeah, exactly. Like
200 gigabytes of data.
Exactly. And spent like 5 hours there left. Got the download like last week. It was unbelievable. Like what was great about it was that I could get basic comprehensive understanding of like my body, what's happening, but also somebody there reporting it out and talk to me through how I understand it, what to do next,
and a plan.
And basically build a plan from there.
Yeah.
It was great. Like I actually purchased it from like I purchased it as well for my parents and things like this. I think it's just a great gift.
Cool.
Yeah.
Dave, we need to get you there too.
Why Orlando and why not somewhere else? Like
I was on the East Coast, so I popped down to Orlando, and so it was just easy for me.
So, yeah, we got New York, Orlando, Naples, Dallas, Houston's opening, Miami, and LA. Yeah. Anyway, back to the conversation here.
All right.
I can imagine this is going to up the value of health in the home a lot, right? So one of my visions of the future is
اینجا تام یک شو فیسی بکن واسه
levels and so forth, and uploaded to figure in the kitchen, cooking your meals, ideally suited for what you need in that moment. And then the whole how do you think about that?
I grew up on a farm, Midwest, and then my parents got into like independent assisted living like 15 years ago. So
they went to
around like senior care.
we went to her family's there,
my parents own
and then
like senior housing.
we just decided to. She wanted to go back, but I couldn't just drop everything and go there. So I said, "Why don't you go for now?"